I'm going to extend this formula a little bit, and hopefully you will accept my reasoning here. We'll see. Okay, now if I take, so I've got here that theta 1 is equal to lambda over b. Alright, we agreed with that. Now I want us to look at this triangle over here. This triangle over here. Okay, that one over there, where f is the distance from the single slit to where it's been projected onto. Okay, and d is the, what I was mentioning there, is from the middle of the principal maximum to the destructive interference point. We can see from that the tan of theta 2 is equal to d over f. Okay, now the same principle that works with sine of theta is equal to theta for very small angles theta works for tan also. Okay, and so your tan of theta 2 we can write as theta 2 is equal to d over f. So this is looking at the relationship between this principal maximum here, the width of the principal maximum, and the focal, and this focus length over here. Now, this is where you may find it a little bit difficult to believe. The next thing I'm going to say is that it turns out that often this theta 2 and this theta 1 are of comparable values. They turn out to be pretty much the same value. Theta 1 approximates to theta 2. Okay, in reality, they're both very small, and we can approximate that they are equal to each other. So I can therefore say that theta 1 is equal to lambda over b, which is equal to d over f. And therefore I can get a formula for my width from this formula. I mean, there's all different ways that I can write this formula, but let's just write it like that d is equal to f lambda over b. And that sort of brings the whole thing, and we can do this experiment, and it's actually quite a nice IA to be done, where we can actually do it here, because in this situation over here, when we were working with this, we can get something that we know the width of that slit over there. So we can know this over here, the b. All right. We can measure that. We can also measure that, and from that we can work out the wavelength of the light. So if you were, for instance, wanting to do an IA on this, you could, for instance, you could keep this constant, you could keep your lambda and your b constant, and you could look at the relationship between d and f. Alright? And then from that you could plot a graph and then find out what your lambda is. Alright, from the slope of your graph. So that would be quite a nice lab to do. I'm not going to make this this compulsory for you to do. If you want to do it after on a Tuesday afternoon, or if you want to do it when we are doing our lab sessions next year, if you want to do this one, this will be a lab that you can do. It's quite a nice lab. You can do lots of application with it. All right. Yeah. Yes, so there would also be a d on up to there on that side. So it goes from the middle of the principal maximum to the end of it, like that. Yeah, so it's for your interference pattern that you get formed. Okay.